Hello my dear class 10 students, how are you all? I hope you are doing amazing. Good morning to all of you. Yes. Good morning everyone. So yes, this is one of the most awaited live that you all have been requesting for, that is the top NCERT activities. We will be discussing top 19 NCERT activities that are given in your NCERT textbook, which is very important for your boards. Yes, do not skip this live at all. And see, CBSE asks a lot of questions from these NCERT activities. So that's why I have compiled all the important chemistry activities, all the activities from chapter 1 to chapter 4. And yes, we will be solving all these activities today only. Yes, are you ready everyone? Okay, so let's start. Let's start with the first activity, my dear students. Do mention your doubts in the chat section. Whatever doubt you have, I will answer them, okay? Now let's start with the first activity. This is your first activity. You have a magnesium ribbon, and if you try to burn that ribbon, if you try to burn magnesium ribbon, what will you observe? What will you observe? So firstly, we know if you burn magnesium ribbon, we are adding what? Oxygen. This is a type of oxidation reaction, right? So whenever you are burning something, what you are doing, you are providing oxygen, and when you provide oxygen to magnesium, what do we get? We get magnesium oxide. We get magnesium oxide, okay? This is in powder form. This is in powder form. And what will you observe? You will observe dazzling white flame. Yes, whenever we burn magnesium ribbon, what do we get? We get dazzling white flames. We will observe dazzling white flames and magnesium powder. And what will form? Magnesium powder will form. Okay. Again, hold it with a pair of tongs. This is written. This is burning process. The thing is, what do you observe? That is your most important question. Okay. From activities, question will come as in case-based form questions, or the 2-3 marker questions, competency-based question they will ask you, right? And question from the activity comes straight in your exams. Yes, this has happened before and is going to happen again. So try to prepare all these activities. If you are done with this, you do not need any other activity. These are all the important activities that are there, okay, in your chemistry portion, okay? So clear? You understood this activity, right? Very easy, the basic one. Next one. Take lead nitrate solution. What is lead nitrate? What is lead nitrate? This is lead nitrate, right? And what happens if we add potassium iodide? Okay, one more thing. Tell me what reaction, what was the name of that reaction? This reaction. What was the name of this reaction? Should I call it combination or should I call it oxidation? Or exothermic? What is the name of this reaction? Next, when you add potassium iodide to lead nitrate, so what do you observe? Again, what will you observe? We know this is kind of a double displacement reaction. What kind of reaction? Double displacement reaction. Yes, it will be combustion, combination followed by oxidation. Combination as well as oxidation. Yes, combination as well as oxidation. Clear? Now here this will be a double displacement reaction. That means there will be an exchange of ions between the reactants, right? So what will happen? We will get lead iodide and potassium nitrate. We will get lead iodide and potassium nitrate. Now this lead iodide is yellow in color. This lead iodide is yellow in color. So we will observe yellow colored lead iodide. Clear? And this is an example of double displacement reaction. How is your Sunday going? Are you prepared? Are you working hard for your boards? 17, you have maths exam, right? So are you prepared for that exam? Because I have seen Sonu sir taking so many lives and he's working so hard for you guys to score 100 out of 100 in maths. So do join his lives, and if you have any doubts, he will be more than happy to assist you. Now, if we treat lead nitrate with potassium iodide, what will we observe? We will observe a double displacement reaction, and a precipitate of lead iodide will be formed, which is yellow in color, right? If you want to balance it, just add 2 here and a 2 here. Now, this reaction is completely balanced. This is a precipitate. What other name we call precipitate? You know, there is one other name of precipitate, and what is that name? Next, activity. As I have written here also, which activity it is from chapter 1.3. The activity is third activity from chapter 1. Okay, so take a few zinc granules. We have taken zinc, right? And we have added either hydrochloric acid or sulfuric acid, both will do. So let's say I have zinc, which is solid, and if I added hydrochloric acid, let's say, which will be liquid, right? And again, do you observe anything around the zinc granules, touch the conical flask and tell if there is any change in temperature. So when this reaction happens, what we get? We get a salt. This is metal, and this is acid. When metals react with acid, we get salt, and hydrogen gas is evolved, right? This is a salt and hydrogen gas is evolved. This is what happens, right? So what will be observed happening to the zinc granules? They will convert into salt, okay? Zinc will be disappearing and we will be getting a salt, which is zinc chloride, okay? Aqueous salt, right? Okay. Next, temperature. Now this reaction is exothermic. Why? Because there is hydrogen gas evolved, right? This reaction is exothermic as there is hydrogen gas evolved, right? And there is an increase in temperature when you touch the vessel. So this reaction is exothermic. That means there is an increase in temperature. Clear? Any doubts you have? Okay, if you have doubt what will happen if we treat zinc with sulfuric acid, then let me clear your doubt. I hope it is visible to you all now. Okay, sorry for the error. Okay, there was some technical issue. I hope it is resolved now. So any doubt? Okay, now then again hydrogen gases also evolved. Again this reaction is also exothermic. This reaction is also exothermic, right? There will be an increase in temperature. Next activity. I can see you, this might not be visible to you all. Let me try to show you. Actually what is happening here, we have calcium oxide. This is calcium oxide and this is water. We added water to calcium oxide, and there in this beaker we are seeing some bubbles. There are bubbles. So the activity asks bubbles. If we take small amount of calcium oxide, and what is the other name of calcium oxide? quicklime, correct. So if we take a small amount of calcium oxide or quicklime and we add water to it, what will happen? Touch the beaker, will there be any change in temperature? What product will be getting formed? So if we add water to it, we will get calcium hydroxide, which is slaked lime. This is quicklime and this is slaked lime. Plus lots of heat will be released. Right? That means this reaction is highly exothermic. Exothermic reaction means lots of heat energy. Heat and energy is released, or heat is released. Okay, that is exothermic. Endothermic means when heat is getting absorbed. That is endothermic. Okay. So this reaction is exothermic. There will be an increase in temperature. Okay. Any doubt till here? It is going smooth, I believe. Hello. Good morning. Hi everyone. Okay. Now, there is again this activity. This girl is heating iron sulfate crystals. Now, if you do not know, this is the formula of iron sulfate. This is the formula of hydrated iron sulfate. Iron sulfate has 7 water of crystallization. Okay. So, she took 2 gram of ferrous sulfate crystals in a boiling tube, right? And now, what is the color of ferrous sulfate? Reply that down, okay? Right, tell me what is the color of ferrous sulfate. Okay, then what she did, she heated the boiling tube over the flame of a burner. Now, observe the color of the crystals after heating. After heating, what will happen? So, firstly, yes, the color is green, correct. The color is green. The color of iron, ferrous sulfate crystals is green. Okay. Now, if you heat those crystals, what do we get? We get iron sulfate plus 7H2O. That means these water of crystallization are lost. These 7 water of crystallizations are lost. Now, what will happen? What will be the color change? This is green in color. This is white in color. Without the water molecules, ferrous sulfate is white in color. Now, what will happen if you do prolonged heating? Let's say if you heat it for so long, you did not stop here and you heated it much more, like one more time, or for some more time you heated it, what will happen? Yes, if you heat it, let's say if I heated it more, prolonged heating, that's what I call it, what will happen? I will get iron oxide plus sulfur, SO2 and SO3, right? So, what will I observe? Color change will be from green to white. And on prolonged heating, there will be a rotten egg smell. These give rotten egg smell. Okay. SO2 and SO3, sulfur oxide and sulfur dioxide and sulfur trioxide, they will give a rotten egg like smell. Okay, so I think you know what will be the color change and what is the observation that you do that you see when you heat it for a long time. Okay, on prolonged heating. Everything clear till now? Okay, let's move on to the next activity. Take about 2 gram of lead nitrate powder. Again there is lead nitrate. What is lead nitrate? This is lead nitrate. Right? Okay. If you have 2 gram of lead nitrate and if you heat it, what will happen? So, if I have 2 gram of lead nitrate and if I heat it, it will undergo what kind of decomposition? Tell me the name of the decomposition. And also tell me how many type of decomposition are there. This is, yes, correct, thermal decomposition, and apart from this we have 2 other type of decomposition which are electrolytic, yes, using electricity we decompose, and using sunlight, photolytic decomposition. Okay. Now, if you do thermal decomposition of lead nitrate, what will you get, my dear kids? You will get lead oxide. Plus nitrogen dioxide plus oxygen. lead oxide, nitrogen dioxide and oxygen. Now what will be the color? What will be the colors you will be seeing? Now see, from lead nitrate, if you do the thermal decomposition of lead nitrate, you will be seeing brown fumes of nitrogen dioxide. Brown fumes of nitrogen dioxide. Clear? You will be observing brown fumes of nitrogen dioxide. Clear? This is called the thermal decomposition of lead nitrate. Next activity, and this is very big one, but I'll point out the major question that is being asked here. So basically it is electrolysis of water. This activity is about electrolysis of water. And we are asked, what we are asked? We are asked which gas will be observed, will just place water in the container, then both tubes, just to remove them carefully. What happens in each case? Which gas is present? Okay. Hold on a second. Okay, so let me just explain you what is being asked actually. The question is, if you have this setup which is used for electrolysis of water, right? You are doing electrolytic decomposition of water, okay? And we are asked, why, 2-3 things we are asked actually. Why we use acidified water? Why do we use acidified water? That means we add acid to water, right? Second thing, which gas will be evolved at anode and which gas will be evolved at cathode? What do you find at anode and what will you find at cathode? Okay, next, what was the other question? Which gas is present and what happens? Okay, and what will happen if you do not take the acidified water? One more question is there. What will happen if we do not take acidified water? Okay, now let's see. Let's discuss each question one by one. Why we are using acidified water? So, we are talking about electrolysis. That means we are providing electricity, and for electricity conduction, we need either ions or electrons. Now, water. We are talking about water. Water is a poor conductor of electricity, right? Water is a poor conductor of electricity. Clear? So, to make electrical conduction easy, make it a good conductor. Make it a good conductor, we add few drops of, we acidified it actually. We acidify it. That means we add drops of sulfuric acid to it. Yes, that means we add drops of sulfuric acid. Okay, so what we were discussing, we were talking about why do we use acidified water? What is the need of using acidified water? So as I have told you, water is a poor conductor of electricity. It will not be able to conduct electricity. So what will happen? The process will not continue, right? Process will not happen because we need electricity for the decomposition. So what do? We add a few drops of acid. What acids have? Acids have H positive. Now these H positive are good conductor of electricity. Why? Because ions and electrons conduct electricity and we have ions, so ions will conduct electricity, okay, for better conduction of electricity. Why do we need electricity? Again, we need electricity because we want to decompose a water molecule, okay. Okay, so that's why we need H positive. Why? Because water is a bad conductor of electricity. And that's why that answer this questions also. That's why we do not use only, that's why we do not take, what happen if we do not take acidified water? So if you do not take acidified water, there will be no electricity conduction and thus no decomposition of water molecule, okay. Bad conductor of electricity. Okay. Next question, what will be you getting at anode and cathode? So when you decompose water, what is the reaction? when you decompose water, what is the reaction you are seeing, my dear kids? Let me write it for you. So, this will be the reaction actually. Now, which gas will be, both are gases, right? Hydrogen and oxygen. Which gas will be at anode and which gas will be at cathode? Answer it right now. At anode, we will be getting, yes, we will be getting oxygen gas at anode, and at cathode, we will be getting hydrogen gas. Clear? This is the electrolysis of water, electrolytic decomposition or electrolysis of water. And at anode, we will be getting oxygen gas. At cathode, we will be getting hydrogen gas. This is important. How do you remember it? H, there is H in cathode and hydrogen also has an H. And in anode, you have an oxygen O. Oxygen is also made up of O, and anode also have O. Simple trick. Okay? Clear? Next activity. If you have silver chloride and if you keep silver chloride in presence of sunlight, what will happen? Firstly, silver chloride. What is the color of silver chloride? Tell me. What is the color of silver chloride? Now, when you keep silver chloride in presence of sunlight, it undergo decomposition. It undergo decomposition. Okay. And what do we get? Silver plus chlorine. Silver plus chlorine. Yes, correct. Silver chloride is white in color. Silver chloride is white in color. Now see, when decomposition happen in presence of sunlight, it is called what? Photolytic decomposition. It is called photolytic decomposition. And what are we getting? Silver and chlorine. Now what is the color of silver? It is grayish in color, right? It is grey in color. And again, chlorine is a gas, it is yellowish green in color. Now see, what will happen, what will be the color change for silver chloride? Silver chloride will turn from white color to grey color. It will turn white, from the white color, it will turn greyish in color. It will turn grey. Okay, it is white, right? Silver chloride is white, but silver is grey in color, and thus because decomposition happened, we will be getting grey color. Okay, clear? Okay, I hope it is clear. Next activity, again we have aluminum or a copper wire. If we place it here, what do you observe after some time? So what is happening actually? You have, if it is not visible, this is a metal wire, either copper or aluminum, any wire you have, and you are burning, you are light this, you have a lamp, you have a spirit lamp here, and here is a pin, here is a metal pin, wax, and here we have some wax. This metal pin is attached to the wire using wax, right? And what will happen if you heat it up, if you pass, if you light this wire, what will happen? Conduction. Because metals are good conductor of electricity. Metals are good conductor of electricity. Now, as metals are good conductor of electricity, sorry, not electricity, both they are electricity and heat actually. Heat. We are majorly focusing on heat here, okay. Now, as metals are good conductor of heat, what will happen? When you heat it up, when you put the lamp or candle here, the heat will pass through the metal, and reaches this wax and melt this wax, because wax has very low melting point, it will melt very quickly and this pin will fall off. The pin will fall off. The metal pin will fall off. So that's what your observation is. Does the metal wire melt? Obviously it won't, because metals have very high melting and boiling point, but there are some exceptions. What are those exceptions? There are some exceptions, right? Which some metals have very low melting point, right? They have very low melting point. In this case, the aluminum or the copper wire, as they have high melting point, they will not melt. The metal wire will not melt. Clear? Next question. Next activity actually. If you have magnesium ribbon and sulfur powder, if you have magnesium ribbon and sulfur powder, and if you burn them, first thing you burn them, okay? Burn means oxidation. If you have magnesium ribbon and if you burn it, what will you get? You will get magnesium oxide. Similarly, if you have sulfur and if you burn it, we will have sulfur dioxide. We will have sulfur dioxide. The question is, if you taste the resultant solution, you collect the ashes and you dissolve them in water. What is magnesium? It is metal. What is sulfur? Sulfur is a non-metal. Metals form basic oxides, right? And non-metals form acidic oxide. So what will happen if you dissolve magnesium oxide in water? If you dissolve, let's say, if you dissolve magnesium oxide in water, we will get magnesium hydroxide. Magnesium hydroxide. And what will be the color change? What will be the color change? The color change will be from red litmus to blue. From red litmus to blue. Now let's talk about sulfur oxide. Sulfur is a non-metal, it will form non-metallic oxide, and sulfur oxide is what? It is acidic. It is acidic, right? Because non-metal oxides are acidic in nature. So if you have sulfur combining with oxygen, we get sulfur oxide. And if you add water to sulfur dioxide, we dissolve them in water. What will we get? We get sulfuric acid. We will get sulfuric acid, and this will turn blue litmus red. This will turn blue litmus red. Now some questions are also there. The solution red litmus. Now burn sulfur also same thing you did from burning sulfur. Yeah, obviously it is acidic. Can you write equations for these reactions? Now these are the equations. Magnesium combined with oxygen, when you burn it, forms magnesium oxide. Magnesium oxide, if you combine it with water, we get magnesium hydroxide, which is a base, which will turn red litmus blue. Again, if you burn sulfur in oxygen, basically if you burn sulfur, you are giving oxygen to it. We will get sulfur dioxide. What is sulfur dioxide? It is acidic in nature, because if you combine it in water, we will get an acid, which is sulfuric acid. Thus it will turn blue litmus red. Next activity, this is a long one, so let me sum it up for you. We have 3 categories actually. Yes, if you have any doubts, again please let me know. So we have 4 categories actually. Some metals react with cold water, some metals react with hot water, some metals react with water vapors, and some metals do not react with water at all. Hot, cold, water vapors, any form you give, they do not react with it. So let's discuss them. It is this category only. So what are the metals which react with cold water? The metals that react with cold water. Let me make a table actually. What happens, for example, sodium or potassium both react with cold water. Now what happens when they react with water? They form sodium hydroxide or potassium hydroxide, plus hydrogen gas is evolved. Which gas is evolved? Hydrogen gas is evolved, plus lots of heat is also released. Now as this heat is released and you have hydrogen gas, this hydrogen gas catches fire. That's why it is said that these metals, sodium, potassium, react vigorously with water. They react vigorously with water. Okay. So if you treat them, you get sodium hydroxide or potassium hydroxide and hydrogen gas, and heat is released. Now we have 3 categories. All metals will react differently. 4 categories actually. Let's write that down. Cold water, hot water, water vapor, and the final one, no reaction. I'll write here, no reaction. Okay, tell me, the one which will react with cold water. The one which will react with cold water is potassium, sodium, calcium, right? Potassium, correct. Sodium, yes. Magnesium, calcium, right? Done. Okay. Magnesium reacts with hot water, right? Correct. Then you have, yes, aluminum, yes, iron, they will react with steam, water vapor. As they are not that reactive, they will react with water vapor. Then you have silver, gold. Is it visible? It is not. Let me clear it. No reaction. Lead, silver, gold, yes, copper also, platinum, copper. These do not react with any kind of water. Now remember one thing, in each case you are getting a metal hydroxide, in each case hot water, cold water, water vapor, instead except this one, water vapor, we are getting metal hydroxide. What we are getting? We are getting metal hydroxide plus hydrogen gas. Metal hydroxide plus hydrogen gas. Only in case of steam, in case of water vapors, we are getting metal oxide. What we are getting? We are getting metal oxide plus hydrogen gas. Clear? Why we are getting metal oxide? Because when you have water vapors, that means the temperature is greater than 100 degrees Celsius. That means the temperature is greater than 100 degrees Celsius. And what will happen if you have the temperature greater than 100 degrees Celsius? At that much higher temperature, only oxygen gas is stable. Only oxides are stable, not hydroxides. Hydroxide decomposes to give hydrogen and oxygen. The oxide they will give, right? When you have hydroxides, they will decompose to give hydrogen and oxides, right? Clear? So that's why we do not use, that's why when we have water vapors, we will get metal oxides, not hydroxides. Clear? Next activity. So it is the reaction between copper and iron, the most famous or infamous reaction, you can say it. Reaction of copper and iron, nail copper via a solution, iron sulfate. You have two solutions actually. You have solution A, let's say, and you have solution B. Okay. What is happening? In one A solution A, you have iron sulfate and you are adding copper to it, and you are adding copper metal to it. In the second test tube, you have copper sulfate solution and you are adding iron to it, Now my dear students, what do we know which is more reactive? In between copper and iron, iron is more reactive. This iron can displace copper from its compound. Displacement reaction, right? More reactive element displaces a less reactive element from its compound. Okay, that is a displacement reaction. So the reaction that we will be seeing here is a displacement reaction. Why? Because iron is much more reactive than copper. Iron is more reactive than copper. So what will happen? What will happen here? In this case, as you have an iron sulfate solution and you are adding copper to it, there will be no reaction. There will be no reaction. But in test tube B, when you are adding iron to copper sulfate, when you are adding iron to a copper sulfate solution, what is happening here? We are getting, because iron is more reactive than copper, it will displace copper from its compound. So what will we get? We will get, this is the reaction, iron sulfate plus copper. What is the name of the reaction? Name the type of reaction. The reaction is displacement reaction. This is the balanced chemical equation. Now tell me, okay, what will be the color change? What will be the color change? As we know, copper sulfate is blue in color. The color changes from, and iron sulfate is green in color. Iron sulfate is green in color. So what is happening? When you put iron metal in copper sulfate solution, there will be a layer of copper on this iron metal. Okay, there will be a layer of copper, and copper is brown in color, reddish brown in color. So there will be a reddish brown deposition on the iron metal. Clear? This color change is clear. Copper sulfate is blue in color, iron sulfate is green in color, and copper is reddish brown in color. Any doubt? Is it clear, everyone? This is clear, right? This is easier one. Okay. Now, let's move on to the next activity. You have some carbon compounds. If you burn them, what will happen? I've combined two activities because both were talking about the type of flame. Now there are two type of flame. You have blue flame and you have yellow sooty flame. Now tell me, when do we get these flames? So blue flame is considered clean. It is clean flame, right? When there is no wastage of fuel, every bit of fuel is burning properly. Combustion, proper combustion is there. It is called yellow. It is called blue flame or clean flame, right? So you have two type of compounds: saturated compounds and unsaturated compounds. Saturated compounds are those which have only single bond. And when you burn saturated compounds, you will get blue flame. You will get blue flame generally. Generally, when you burn saturated compound, you will get a blue clean flame. And when you burn unsaturated compound, what are unsaturated compound? They have double or triple bonds. Compounds that have double or triple bonds in between them, right? Carbon-carbon double bond, carbon-carbon triple bond, right? They are unsaturated compounds. And when you burn unsaturated compound, generally you get a yellow sooty flame, right? For example, you have seen LPG cylinder, right? When you switch on the gas stove, you get blue flame. That is clean flame, right? Because the LPG is burning completely. Now, if you collect some wood scraps and everything, leaves, and when you burn it, you get yellow sooty flame. There is soot, black color soot is there, right? There is smoke soot, and then you have this yellow flame of that yellow flame when you burn it, right? That is yellow sooty flame. So normally, generally, saturated compounds give blue flame, unsaturated compounds give yellow sooty flame. We have naphthalene, copper, alcohol. Now tell me, naphthalene balls. Have you tried burning naphthalene balls? And okay, you know camphor, right? Camphor. Does it give yellow sooty flame? It gives blue flame, right? Camphor gives blue flame. What about alcohol? Alcohol also gives blue flame. Naphthalene balls, have you tried burning naphthalene balls? What kind of flame will they give? Yes, yes. Yes, okay. So naphthalene balls will give, yes, they will give yellow flame. So we will get yellow sooty flame will be given by naphthalene balls. And then camphor, blue flame will be given by camphor and alcohol. Okay. Whether you get smoke, in case of naphthalene, we will get smoke, deposition in the plate, no deposition as such. On the plate, if in case, deposition will be there for camphor. For camphor, there will be deposition, right? Because it is changing directly from solid to gas, right? And if you not, okay. Bunsen burner and adjust the air hole type of flame, okay. If you adjust the oxygen supply, now that was I said generally, but what happens, my dear students, what happens that when you do not have sufficient oxygen supply, when you have less oxygen, limited oxygen supply, whenever you try to burn anything in limited oxygen supply, it will give yellow sooty flame. It will give yellow sooty flame. So even with saturated compounds, if you burn them in limited oxygen supply and when the oxygen supply is less, what will happen? They will give yellow sooty flame. And if any unsaturated compound, they are burned in plenty of oxygen, unlimited, pure oxygen is there, okay? For example, when you're doing welding, you take ethine actually and you burn it in pure oxygen. You have an oxygen cylinder, you burn it in pure oxygen. When you burn an unsaturated compound in pure oxygen, you get blue clean flame. You get blue clean flame. So that's why I added the word generally and emphasized it. Why? Because yes, sometimes what happens, unsaturated compound may give blue flame and saturated compound may give yellow sooty flame depending on the oxygen supply. If the oxygen is less or very little oxygen supply is there, we will get yellow sooty flame. If the oxygen supply is more, unlimited supply we have, we will get clean flame. Okay, so remember, instead of remembering on the basis of saturated, unsaturated, remember it on the basis of oxygen. Less oxygen, yellow color. More oxygen, blue flame. Okay, I hope it is clear now. Next activity. If you have ethanol, what is ethanol? It is an alcohol, right? This is ethanol. Or what can I write? Yes, both are same, my dear students, both are same. If you have any doubt, because I have actually many students have complained, ma'am, is this same or not? They are both same, because what we are doing, this is ethanol, right? And we just count the number of carbons, 2 carbons, 3 and 2, 5 hydrogens, 2 carbons, 5 hydrogens, and there is an OH. So same, right? We just condensed it. This is just called condensed formula. Okay. So what happens when you have ethanol and you add 5% alkaline potassium permanganate? Alkaline now I don't know if you know it or not, but alkaline KMnO4 is a very good oxidizing agent. It is a good oxidizing agent. Now what are oxidizing agent? Tell me. What are oxidizing agent? Oxidizing agent. Tell me the oxidizing agent. Yes, oxidizing agent Okay, so oxidizing agent, correct. Oxidizing agent are substances that add oxygen, right? That supplies oxygen so that you can add oxygen, right? So what they do, they add oxygen. Simple definition is add oxygen. And there is one more, that oxidizing agent oxidizes others and reduces themselves. They oxidizes others and reduces themselves. That is oxidizing agent. I hope it is clear. So when ethanol is treated with an oxidizing agent, what happens? It gets oxidized. That means one more oxygen is getting added. Now if we add one more oxygen, what will happen? If we add one more oxygen, what will happen? We will get an acid. We will get an acid, right? Same, almost same, right? So if you add alkaline KMnO4, 5% alkaline KMnO4, potassium permanganate, it is a good oxidizing agent. It will oxidize the ethanol to ethanoic acid. It will oxidize the ethanol to ethanoic acid. Okay. Now one more thing is there. It is asked what will be the color change in case of potassium permanganate. So if potassium permanganate is purple in color, right? I have seen it sometimes because it is purple in color. When you add it to water, it turns the water purplish, right? It is used as a disinfectant also when you want to purify water. You use potassium permanganate to it. So what happens? The color, purple color, the color which was purple, this was purple color, it disappears. After this reaction, in this conversion, the color disappears. Okay, but the question is slightly different. What does the question ask? It asks, if we add excess of potassium permanganate, what will happen? So initially, if you are just adding the amount that is required for converting ethanol to ethanoic acid, then the color will be disappeared. Then the color will disappear. Okay, all the purple color will be gone. Why? Because all the potassium permanganate is used to convert ethanol to ethanoic acid. But if you add too much, if you add excess of potassium permanganate, what will happen actually? So the potassium permanganate the color. It will not lose its color if you add in excess amount. Why? Because this conversion has happened. All the required potassium permanganate has been consumed. After that, whatever amount you add, it will be excess. After that, whatever amount you add, it will be excess. There is no ethanol to react with. There is no ethanol to react with, and further oxidation is not possible. This is the final product. After this, no other oxidation will happen. So, if you add excess of potassium permanganate, it will retain its color. It will retain its color. It will retain its color. That means the solution will be purplish. Clear? So, if you add excess potassium permanganate, initially the amount was used to convert ethanol to ethanoic acid. After that, each amount is extra, right? And this extra amount is, and this extra amount, yes, this extra amount will retain its color. There is no conversion, there is no reaction happening, right? You know, all the reactant is consumed. Okay. Next activity, you have sodium, right? And if you drop sodium in ethanol, this is ethanol, and if you drop sodium in ethanol, you know the reaction, right? Sodium is actually it is used as a test for ethanol. This is a test for ethanol to check whether ethanol is there or not. Now, what is this test? So, when you add sodium to ethanol, we get sodium ethoxide. This is sodium ethoxide. And hydrogen gas is evolved. How will you test the gas evolved? How will you test it? So, first thing, because we have a solution, we have alcohol solution, we are adding sodium to it, there will be bubbles of hydrogen gas, and what they cause brisk effervescence. Again, let me clear it for you. Effervescence means there is bubbling of gas. Bubbling of gas is called effervescence. And when you add sodium to ethanol, there is effervescence of hydrogen gas. There will be bubbles of hydrogen gas in that solution. Okay? So, it will show brisk effervescence. Clear? And that's how you test it. Okay? What is one other method of testing hydrogen gas? What is the other method? You can test hydrogen gas using a candle also, right? Yes, what do you do normally? So, when you have a candle and you bring it closer to hydrogen, when you have a burning candle actually, and when you bring it closer to a source of hydrogen gas, it will burn with a pop sound. Right? That is one other test that you use for checking if there is hydrogen gas evolved or not. But in this case, we have a solution. So, in this case, we will be seeing this brisk effervescence, that is your bubbles of hydrogen gas in the solution itself. Next activity. Everything going good? Clear? These are very important. Okay. So, do always, do them before your exams, and every day, whenever you're studying science, take these activities are very important. Do not skip them if you're reading from NCERT. Okay. If you have sodium carbonate and ethanoic acid, what will you observe? And if you pass that gas through lime water, what will be the observation? And if you repeat the same activity with sodium hydrogen carbonate instead of sodium carbonate, again tell me what will be your observation. So, let me do both. So, when you have sodium carbonate, this is sodium carbonate, right? And if you react it with ethanoic acid, this is ethanoic acid, right? What will happen? We get a salt. What is this salt called? What is the name of this salt? And water. And the gas evolved is carbon dioxide. This is how sodium carbonate reacts with acetic acid or ethanoic acid. Correct. This is sodium acetate. Okay, now if you have sodium acetate, right, which gas produced carbon dioxide? Again, if you pass carbon dioxide through lime water, this is lime water, and if you pass carbon dioxide gas through lime water, we get calcium carbonate plus water also. Now this is milky. This is milky. So that's what we call it. This gas, carbon dioxide, turns lime water milky. Carbon dioxide turns lime water milky. Clear? Okay. Now see, sodium acetate we are getting. Can you identify the gas? Can the gas produced by the reaction between ethanoic acid and sodium carbonate be identified by this test? Yes, it can, because the gas is carbon dioxide, and if you do the lime water test, yes, carbon dioxide gas will turn the lime water milky, so it will give the test. Now it is asking, the activity is asking, okay, that what will happen if in place of sodium carbonate we use sodium bicarbonate? Do not worry, same thing will happen. Same thing will happen. We will get a salt, water and carbon dioxide. Again, same thing. Okay, let's do that reaction also. If you have sodium bicarbonate and you treat it with acetic acid or ethanoic acid, what will happen? We will see, again we will get a salt, sodium acetate plus water plus carbon dioxide gas is evolved. Plus carbon dioxide gas is evolved. Clear? Now again same reaction, right? Same reaction, same products, same gas. Again we can test carbon dioxide by passing it through lime water. It will turn the lime water milky. Next question. This is from the chapter 2 actually. So you are given a bunch of solutions. Let me mark it. We have HCl, H2SO4, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, ammonium hydroxide, magnesium hydroxide, potassium hydroxide. So some acids are there, some bases are there, right? And we are asked if what will be the color change in these cases. Let's start with the one. Let's start with HCl. Okay, let's start with HCl, right? Okay, HCl is a strong acid. It will convert red litmus solution to nothing, no change. In case of red litmus, no change. What it will do, it will turn blue litmus into red. Blue litmus into red. Phenolphthalein. Phenolphthalein is colorless in acidic solution and pink colored in basic solution. As we have a strong acid, it will remain colorless. That means no color. This means no color. Methyl orange. Methyl orange, again it is red in case of acidic solution, and in basic solution it is yellow. Red in acidic solution and in basic solution it is yellow. So the color will be red again. Next, let's say for sulfuric acid, for nitric acid, same thing, no change, no change. Blue litmus red, blue litmus red. Phenolphthalein colorless, colorless. Methyl orange red, red. Okay, now the next one, again acidic acid is also an acid, but it is a weak acid. Acidic acid is a weak acid. Again it will not change the color. Red, no color, again red. Okay, tick means red. Now let's move on to the bases. These all are bases, but you know sodium hydroxide, calcium hydroxide, magnesium hydroxide, potassium hydroxide, these four are strong bases and this one is weak base. Ammonium hydroxide is a weak base, but even if it is basic or acidic, they will all show the same color change in case of indicators. Okay, different color, you know, in case of sometimes if you have a weak base, so in place of yellow color they show orangish color. Okay, methyl orange will show orangish color. Okay, if it is near to neutral solution, at neutral methyl orange is yellow, right? So if you are going from yellow to orange, that is from neutral to basic. Clear? Depends on the pH level. Okay, that doesn't matter, but this will be the conversion. Let me write it. In case of sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide and ammonium hydroxide. Red litmus, yes, red litmus will turn blue for all of them. Okay, blue litmus, no reaction for all of them. No change, right? For blue litmus there will be no change. For phenolphthalein, the color will be pink for all of them because all are basic. Clear? For methyl orange solution, again the color will be yellow. The color will be yellow for all of the solution because these all are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, done. These will be the color change that we will observe. That is okay. Next activity, probably this is your last activity, I think. Okay, so the teacher set the apparatus, they took dilute sulfuric acid, added zinc granules. What will you observe on the surface of zinc granules? So what happens actually when you have zinc and you add, when you have actually dilute sulfuric acid. If you have dilute sulfuric acid and if you add zinc granules, zinc to it, what will happen? This is metal, this is acid, we will get salt and hydrogen gas. What will be the salt? Zinc sulfate plus hydrogen gas is evolved. Okay. Now what will you see actually? We will observe on the surface of zinc there will be hydrogen bubbles. There will be hydrogen bubbles. So what we will observe? Hydrogen bubbles on the surface of zinc. Next question. Now pass the gas being evolved through the soap solution. You have a soap solution. Here you have a soap solution. If it is not visible, this is a soap solution. So if you pass the gas evolved, which is hydrogen gas, through the soap solution, what will you observe? If you observe, what will you observe? You will observe bubbles of hydrogen gas, right? Hydrogen gas, if it get mixed in the soap solution, and you will get bubbles of soap bubbles, right? Hydrogen will try to escape the solution, right? You will get soap bubbles. Take a burning candle near a gas filled bubble. So if you take, these soap bubbles have what? Hydrogen in them. These soap bubbles have hydrogen gas in them, and if you bring any burning candle near these bubbles, if you bring any burning candle near these bubbles, what will happen, my dear students? Yes, it will burn with a pop sound. There will be a pop sound you will hear. Okay, the flame is there, but there will be a pop sound. Repeat this activity with some more acids like sulfur, HCl, HNO3, CH3COH. Are the observations same in all the cases or different? So for these, for hydrochloric acid, for nitric acid, we have the same observation. Now tell me, will there be change in observation if you use acetic acid? Answer me, what will there be a change? Because these are all are strong acids, right? But acetic acid is a weak acid, so there will be some change, right? Yes, some of you are answering correctly. There will be a change. Again, we will be getting a salt and hydrogen gas, but the reaction will be much more slower. We will be getting less bubbles, right? The reaction is happening really slow. Why? Because the acid is extremely weak. Okay? For acetic acid, for CH3COH, the bubble formation will be slower. As it is a weak acid, okay? As it is a weak acid. Okay. Now one more activity we have. Okay, this is, see, we have solution of glucose, alcohol, hydrochloric acid. What do we have? Glucose, alcohol and hydrochloric acid. What happens, you have this setup. I don't know if it's visible or not. It is visible. Okay. So what happens here, actually you have this cork, you screwed two metal nails to it and you connected these to a wire. This solution you varies. One time you take glucose, then you take alcohol, then you take hydrochloric acid, and we are asked what will happen to the electricity if you have alcohol solution, let's say. So what will happen? Will the electricity pass? Will this bulb glow? Will this bulb glow or not? If you add this glucose solution here, will the bulb glow? And if you add HCl, will the bulb glow? So the simple explanation is, yes, the bulb will glow, but only in one case, in case of HCl. Why? Because hydrochloric acid is a strong acid, it will dissociate as H positive and Cl negative. And because we have ions here, because of the presence of these ions, what will happen? Because we have these ions here, they will conduct electricity, and if electricity conduction is happening, this bulb will glow. What will happen if we have glucose and alcohol? In case of glucose and in case of alcohol, my dear students, we have carbon, hydrogen and oxygen, right? We have all these three atoms, but they are not polar. They are not polar. What is polar means? Polar means they do not have pole. They do not have charge separation. There is no positive negative charge in alcohol and glucose. There is no positive negative charge. Okay. For acid, this acid we have H positive, Cl negative. There is separation of charges, right? But in case of alcohol and in case of glucose, there are no charges. Why? Because they are polar. They are non-polar compounds. They are non-polar compounds, okay, covalent compounds. Clear? They are formed by electron sharing. There is no electron or ions or charges there that will conduct electricity, right? Electricity conduction is done by two ways, ions and electrons. Neither of them are available in case of alcohol and glucose. So they will not, the bulb will not glow in case of alcohol and glucose solution. It will glow in presence of HCl solution. And that was all the important activities, the top 19 activities from your NCERT, and these all are done. Now do like this session, okay? Do give it a like. Please do not leave without giving a like, and subscribe to the channel if you want to learn this interestingly. And take care. All the best for your boards, and don't be too tired. And we have some time, right? We can score good marks if we work hard now. Take care. Bye bye.